angles. So how do I fill this table? Use a calculator. Make sure you put it in radian mode, shift mode. Press 4. It's on radian R. Make sure it's on radian mode. So now we're going to calculate this. Calculate the first one. Sine 1 equal. Round to two significant figures, 0.84. 0.84. To the next one. Sine of 0.5. You get 0.48. 0.48. Right, good. Okay, we'll keep going. Then we'll do sine of 0.1. 0.1, we get 18 on the first booklet. 0.02 significant figures, that will be 0.010. No, 0.10. Yeah, 0.10. 0.10. And then we'll do the next one. 0.08. We get 0.08. Okay. Do the same thing for tan. Do the same thing for the next two. Fill in this table using your calculator. So if you need to borrow one, see me. I will have it in my drawer. So take out your calculator. Do this now. Alright, let's continue. Do that. So do tan now. So tan 1, which is 1.5, 2 significant, so it will be 1.6. 1.6. Next one, 0.5. You get 0.55. And then next one is 0.1. You get 0.10. And then 0.08. You get 0.08. Okay, so we did it for sine and tan. Hopefully notice something. As x gets smaller, approaching 0, what do you think about the value of the connection between sine x and x? What do you find their values? They look the same, right? 0.1, 0.1. They look the same. So when x approaches 0, the value of sine x and x are almost the same, isn't it? Sine x is approaching x when x approaches 0. And same for tan x as well. Tan x is approaching 0. Tan x is approaching x as well. Because the x value and the sine value and the tan value, they all become very close to each other. Okay, let's see what happens when we do sine x over x as well. Let's continue. So we'll do sine x over x, so we'll do fraction sine 1 over 1. We get 0.84. And then 0.5, 0.5, we get 0.96, 0.96, and then we're going to continue 0.1, 0.1, 0.1, we get 0.10, no, or just 1.0. And then 0.08, 0.8, 0.8, you get 10 as well. Okay, so we see sin x over x approaching 1, isn't it? When you divide sin x by x when x approaches 0. Let's do it for tan as well. Let's do it for tan. So do tan 1 over 1. And 1 over 1, 1.6. And then the next one, 0.5. 0.5. Work out. 1.09. Or just 1.1, right? 1.1. And then do more. 0.1. 0.1. And you will get 1.0, and then more, and then you get 0.8, 0.8, you get 1.0 again. So we see that as x approaches 0, sin x over x approaches 1, tan x over x approaches 1. How about cos x? Does it work with cos x? So you do it with cos x, so you do cos 1, you get 0.54, 0.54, and then cos 0.5, you get 0.90, no, not 90, 0.88, okay, 0.88. And then if you do more, 0.1, you get just 1.0. So it's approaching 1, and then the next 1.8, you get close to 1. So cos x and x, they are different, isn't it? So as x approaches 0, the value of cos x and the x value are completely different, whereas the sin x over x, whereas sin x and tan x, they become the same as x, but the cos x is different. And in addition, you can do this. Now, what if you change it to degree mode? Would it still work? Let's try with degree mode. Shift mode, degree. So let's do sine 1. You get 0.017. 0.017. So that you have to do in degree mode. And then the next bit, 0.5. You get 0.0087. 87, and then if you do the next one, which is 0.1, 0.017, and the last one, 0.08, you get 0.0014. Okay, so the problem with this one, they are different, isn't it? They don't match. Does not match if they are in degree mode. So it has to be done in radian mode. Does not match. Alright, so what do we do now? We can now make a conclusion. Actually, we can examine the graph. So this is the graph of sin x. This is the graph of tan x. This is the graph of x. Right? As x approaches 0, can you see the three graphs? They all meet, isn't it? And if I enlarge this, so I zoom in, I get to see here. So as x gets very small, the three graphs almost become the same, isn't it? So that's what you see there. So when x approaches 0, 0.1, 0.08, the y value become identical. Okay? As x approaches 0. So we see that as x approaches 0, the three graphs, so sin x approaches the x value, tan x approaches the x value, as you see from the graph, because they're all going towards the same graph. And then we have these following limits, which you have to memorize. So these results needs to be memorized. So we saw that sin x over x, as x approaches 0, approaches 1. So you put 1 here. And then x approaches 0, tan x over x also 1. Okay? And it works for reciprocal as well. If you reciprocal that, you also get 1. You also get 1 for that. So these results need to be known for your extension 1 exam. This is extension 1. Okay? Not on the formula sheet. So you need to know this. Okay, good. So after this, we're going to do some examples, and then you can try the exercise. All right, let's do the examples. So how do I use this to do the example? So if there's a number in front, you can take the 2 over 3 out. So write 2 over 3 times lim x approaches 0 sine x over x, right? So the number in front of sine and the number in front of x can be taken out. Now what does this become? This become 1. 1. Okay, we use this result. That become 1. And then you say equal to 2 over 3 times 1. So the answer is 2 over 3. 2 over 3. 2 over 3. 2 over 3. 3. 3. Okay, good. How about the next one? The next one, what you do is, now you cannot take this 4 out. See, this 2 you can take out, but the 4 cannot be taken out. So you take the 3 out first. So you get limit x approaches 0. You take the 1/3 out, and you write tan 4x over x. That's your first step. Take the 1/3 out. So if you can't take 4 out, what do? You just have to put a 4 in the denominator. So these two has to match. Okay? So if you have a 4 inside the angle, you also have to have a 4 in the denominator. And once we add a 4 in the denominator, we have to compensate it by putting a 4 on the top. Okay? Put a 4 at the bottom, put a 4 on the top. And then, as long as these two numbers match, that become 1. Okay, that become 1. So I'm really using this result. That become 1. So you write 4 over 3 multiplied by 1, which is just 4 over 3. Yeah. Okay, note the strategy I just used. Okay, alright, after we do this, we'll do the third one. Alright, how do you do the third one? The third one is not on there, but we can make it look like the one on the top. So the third one, you have to split into 2 parts. Write limit x approaches 0, sine 5x over x times x over sine, that's a top, it's a tan. Sorry, that's a tan 5x. Tan 5x, x over sine 1/3 x. Okay. And then what do you do after this? So I put an extra x in the numerator, extra x in the denominator, so they cancel out. And then you can split that into 2 parts. So you write limit x approaches 0, tan 5x over x times by the limit x approaches 0, x over sine 1/3 x. So that means once you have an x at the bottom, x on the top, you can use one of these 3 formulas. Okay. Now, like before, you have to add something in the x, in front of x, so that you can work out the limit. So what you're going to do is, because there's a 5x here, you need to put a 5 in the denominator. And to compensate this, you put a 5 on the top. Okay? Alright, and then how about the other one? The other one is you got a 1/3 here. So you put a 1/3 in front. And then do 1 over 1/3. 1 over 1/3. Alright, let's work this out. So once you do that, then you can say that's going to be 5 multiplied by 1. Because once they match, the limit as x approaches 0, this becomes 1. And then times by 1 over 1/3. 1 over 1/3 is just 3. Right? 1 over 1/3 is 3. Times by 1. And then your answer will just be 15. So you need to show this working in the test to get full marks. Right, that's all done. So note the working down. These are the working. And on the next page is the exercise you have to do, which you will do it in your book with full working. So you need to show this working. You can't just look at it and say, write 2/3 with no working. You have to show how you got the 2/3, like the other 3 as well. All right, any question before I start on the other booklet? Okay, no question. Okay, now just remember to do this in your book. These are from the Cambridge. There's answers for you to check. So try this, complete the following your exercise book. Okay, good. So this booklet is finished. So go to the other booklet. So we have to continue with the graph from yesterday. So we're going to go to this one. Okay, so we're going to go to page 6 first, and we'll go back to page 5 after we finish. Go to page 6. All right, page 6, please. All right, page 6, please. So we're going to draw the graph of sec x. How do I draw sec x? Now remember, sec x is related to related to cos, 1 over cos x. So we have to reciprocal the cos graph. So I drew the cos graph for you. There is the 2 pi, there's the pi, there's the pi on 2, there's the 3 pi on 2. 0. Okay? So what we're going to do is we're going to draw the graph of the reciprocal. Now let's reciprocal cos x. So remember, when we reciprocal 0, it becomes an asymptote. So we can't have 0 in the denominator. So every time you see a 0, put an asymptote as 0. And then there's an x-intercept become an asymptote. That's your first step. Now when you reciprocal at 1, it becomes 1, isn't it? Reciprocal -1 also become -1. So these points don't change. So put a dot here, put a dot here, put a dot there. And then what you do is you just follow the asymptote. So it's going to go approach the asymptote here, approach the asymptote, approach the asymptote, and then approach the asymptote. That's your sec x graph. Let's make it a bit bigger. Sec x. Use the same strategy to draw cosec x. It's exactly the same method. Okay, have a try. So sec x is drawn. So start with the x-intercept, which becomes the vertical asymptote. The stationary point stay the same, and then just go the other way. Just go towards the asymptote. Go towards the asymptote, asymptote. Okay, try to draw the cosec graph. Okay, let's continue. Cosec x. Alright, start with the x-intercept, put an asymptote here. X-intercept, another x-intercept, put an asymptote. Another x-intercept, put an asymptote. Like that. And then put 0, put a 1 here, -1, these points don't change. Right, like this. These 2 points. And then you just go towards the asymptote. Go towards, go towards, go towards, go towards. Done. That's your sec graph. So draw the asymptote first. So first step, draw vertical asymptote at x-intercept. And then second step is to plot the points on x on max and mean point. Yeah, put that away. Okay, and then you're going to then you just draw the graph approaching asymptote. Draw graph approach asymptote. Right, so it's pretty easy. Okay, got one more. We've got sec and cosec. How about cot. Let's go to cot, which is this one, which is the reciprocal of tan. All right, so the previous page, I want to show you again. Yep. Sorry. Go up, this one. Go down. Yep. All right, hopefully I'll finish. Okay, let's go back. Okay, let's try this one, the cot graph. So what I do is, let's try to draw the tan graph first. Remember the tan graph look like this. That's the tan graph. Tan graph. That's your tan graph, right? So that's 2 pi, 3 pi on 2, pi, 3 pi on 2, 0. Okay? Alright, so we're going to use the same strategy. Every time there's an x-intercept, you draw a vertical asymptote. X-intercept, x-intercept, x-intercept. Like that. So vertical asymptote at the x-intercept. And then what you do is, where there's an asymptote, it becomes a 0. So you do the reversal. So where there's an asymptote before, there's a 0. 0. And then what you do is just go towards the asymptote. See the green dot? Go towards the asymptote and go towards the other asymptote. Like that. Go towards this asymptote, go towards the other asymptote. Done. That's your cot graph. Y equal to cot x. Right, now we know how to draw the reciprocal of all the trigonometric functions. Okay. And then we'll do a hard transformation graph, and then we should be done. Actually, we'll do example 20 first, then we'll go back to example 15. All right, go to page 13 first. We'll do page 13. Page 13. Okay. Page 13, this example. Yes. All right. The question say, how many solutions does this equation have in this domain? So to do that, you have to draw the graph. Draw graph. Okay, so we're going to draw the graph of cos 2x. Now remember how to draw the graph of cos 2x. You have to find the period, which is 2 pi over 2 pi. Okay, so you put 2 pi here, pi on 2, 3 pi on 2, 0, that's 1 and negative 1, like that. Page 13. And then what you do is we're going to, now the period is pi, so you expect one full cycle of cos graph in this region. That's one period. So you have to divide that into 4 parts. So you're going to divide into halfway, halfway. Okay? Halfway, halfway. Alright, so the cos graph starts from the top, goes to the middle, bottom, middle, top. So draw one cycle of cos, and then draw another one, dot, 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 dot. Okay, so you draw the cos 2x. After you draw cos 2x, you have to draw the other graph. you have to draw y equal to, so when you solve this equation, you drew this one, now you have to draw this one, y equal to x over 4 on the same number plane. How do I draw that? We should do a table of values. So maybe you just go x, y. Now substitute 0, substitute maybe pi over 2, and then pi into your formula. So you can just use your calculator. And substitute 0 is 0. Substitute pi on 2, so you do x, which is shift pi over 2, and then you just divide by 4. You get 0.39 on 1 decimal place, so 0.4. Okay, and then substitute pi in there. Actually, yeah, substitute pi, shift pi, you get 0.8. Okay, so plot these points. So make sure you use the same scale. See, this is 1. Notice this is 1 here, and the pi on 2 is about 1.5. That's why this is a bit longer than this one. So this is 1, this is 1.5. Okay, so when x is 0, y is 0, put a dot. The next point at pi over 2 is 0.4. So pi over 2 is here, 0.4 is about here, which is a little bit less than halfway. And then the next one, when x is pi, y is 0.8, so a little bit below 1. And then if you join the dot, so use a straight line to draw the dot. So get arrow, draw a line in blue, in purple. Okay, all right, let's try to draw this. Okay, so it looks something like this. Use a ruler. Okay, works. I think it's good now. This. Okay, good. So there's your straight line. And then we'll go back. Go back here. And then go here. Okay, good. And right, so this is y equal to x on 4. The other one is y equal to cos 2x, y equal to cos 2x, like this. And from the graph, we can see a few things. We can see from this graph, when we try to solve this equation, between x between 0 and 2 pi, in this region, how many solutions would it have? How many solutions? So there's 1 here. Let's do a red pen. There's 1, 2, 3. 3 solutions. So 3 solutions. So because there are 3 points of intersection, so you say therefore 3 solutions. So exam question could ask you to find how many solutions by drawing a graph. Okay, so there are exercises for you to practice this in the textbook. So know how I do things. Make sure you use the same scale on both. So this is 1. This is about 1.5 for the pi. For the pi on 2. Okay, then we have 2 graphs to go through. So after this, go back to page 7, and then we'll finish. All right, all done? Okay, let's move on to the next page, previous page, page 7. Okay, page 7. We're going to draw this graph. So this graph is a bit harder. So we're going to draw this graph. It has a 2x there. There's a pi over 2. Okay. So what do? We can do that by sketching cos 2x first. Let's get this graph first. So write down the amplitude, which is 3. The period is 2 pi over 2, which is divided into 2 pi into 2 parts. Okay? And you divide each period into 4 parts because there are 4 quadrants. So in here, you're going to write 2 pi at the end, divide it into 2 parts. So go halfway, which is pi. And then after you go halfway, you divide into 4 parts. So go half, half, half. Again, half, half, half. Or you can use a ruler, but going halfway is actually not too hard, so you can do it manually. Put a 0. And then let's write down the numbers. This is pi on 2. This is 3 pi on 2. Okay? Remember, the period is pi. What's the amplitude? The amplitude is 3, so we're going to draw 3 here and put -3 there. That's your amplitude. And then we're going to draw the cos 2x graph. So let's draw the cos 2x graph. Cos 2x, so we'll be starting from the top. And then go middle, go there, there, there. Okay, so you draw once, and then repeat it again, twice. Okay? Right, so that's the cos 2x graph. So y equal to cos 2x. Alright, we'll see you. Yep. Okay, good. So draw the cos 2x. So do that first. Give you 1 minute, and then we'll go through the graph we're going to draw. Okay, all done? Now we have to draw this graph. Now how do I draw this graph? What you do is this. Let's write it over here. So what we do is we're going to write y equal to 3 cos. And what you need to do is to factorize the 2 out. To bracket x plus, so that's pi over 2 will be pi over 4. You can check this by expanding. Okay, and see that 2 times pi over 4 is pi over 2. So it's pi over 4. So what you need to do, comparing these two, the actual shift is actually shift to the left, pi over 4 units. So it's this pi over 4 you're shifting, right? So you get pi over 4. So let's put pi over 4 here. So that's the amount of shift you have to do. 3 pi on 4, 5 pi on 4, and 7 pi on 4. So you're going to shift pi over 4 to the left. So we're going to shift our graph to the left, pi over 4 units. So you start from the leftmost, because you have to factorize the 2. So it's like substituting. It's like substituting this into this graph, isn't it? So it's like this graph. So you start with y equal to cos 2x, but then you're going to write cos 2, change the x into x plus pi on 4. And when you change it, that means shift to the left pi on 4. So you change x to x plus pi on 4. So that's why you have to take the 2 out. Okay, so basically you have to change. So when you change this graph, so when you draw this graph first, your next step is to change x to x plus pi on 4 in order to get this graph, x plus pi on 2. So you're going to go to the left pi on 2 units, so pi on 4 units. So you go left pi on 4, so you get this point. Go left pi on 4, get this point. Go left pi on 4, get to this point. And then you keep doing 1, 2, 3, 4, 5. Okay? So you join the dots, so you get this graph. And then just extrapolate. So this graph is y equal to cos 2x plus pi on 2. Alright, so it's done. Right, all finish? Finish? Good. All done. Give you a few more seconds. Alright, let's move on. Okay, next one. Okay, now we can also do it in a different way. You can do the shifting first. So you can do the pi on 2 first. So do the shift first. So we'll go 2 pi, and then pi on 2, 3 pi on 2. You can do the shift first. So we're going to draw the graph of cos x. So that's 3, negative 3. So I'm going to draw in dotted line. So dotted. So you do that first. So draw the graph of cos x. We're going to move left pi over 2 units. Move left pi over 2. So we'll draw the actual graph, which is this point, this point, this point, and this point here. And join the dots, we get this one. Like this, alright? So draw this. After we shift to the left, so this graph is y equal to cos x plus pi on 2. And then we change the x into 2x. X into 2x. And when we change x into 2x, that's where the period changes. So you're going to change the period into period, you now become pi. So what you do is you're going to, so if it's pi, so this whole thing will now be into this section here. You draw the same graph but with a shorter period. So you get this, right? And then it just repeats. Like this. Okay, so which is same as what you get before. Which is same as before. So if we compare, you get the same one, isn't it? So like this. Like that. Okay, so you draw this bit to the same, yeah. Okay, so you get the same graph. Again. Okay, so which way is easier? I recommend method 1. I think method 1 is better. Method 1. But if you want to shift first, if you want to do shift pi on 2 first, you have to do the shift first. Then then change the period. But if you do it the other way, if you're going to change the period first, then do shift of pi on 2, that would be wrong. So you either do, so that there's 2 ways. So you either do the graph of 2x first, cos 2x, then do y equal to cos 2 bracket x plus pi on 4, or you can do y equal to cos x plus power 2, then do cos 2x power 2. So you can only do one of the two ways. Y. Okay, done. Okay, any questions? So this can be done in two ways. So I recommend you do method 1 because it's easier. So you do the graph of cos 2x and then do the shift. Alright, so today what you need to do, you have to do 2 exercises. So you're going to do the rest of 5.7 and also 5.8. Let's do it in red pen. Red. Okay, so you have to do this, and also the small angle. So do this one first, do this one second. Okay? So today's date is 15th of May. 15th of May. I will go back to the graph so you can still see it. Okay, good. So we'll finish. So start the exercise now. All of